Hey, how's it going? It's Mr. Vargas here, looking to help out Math 6 with homework 8.4 from page 607, multiple representations of functions. Before we get started, I just want to quickly recap the idea of functions. So functions usually have inputs, rules, and then you get outputs. So furthermore, there are different ways that we can show functions or we can represent them. And there are three main ways that you need to remember. The first one is simply by tables. So we've looked at these before. Tables where you have a list of x values and a list of y values. So that could really be anything. This is just an example. But you have tables. They can be vertical tables or horizontal tables. The second thing is equations. We can represent functions using equations. For example, y equals 2x. Well, actually, let me go back. Y equals x plus 2. That would be an example of an equation for a function. And then the third way that we see most often is by graphing functions. When we use graphs to represent them. So if I were to graph that equation, y equals x plus 2, on the Cartesian coordinate plane, here's my x-axis and my y-axis. Make my little hash marks. And if you were to see me graph that equation, y equals x plus 2, it would look something like this. And pretty much it would be a straight line. This is a linear function. It creates a line. And you could do that forever in both directions. So there you go. You got three ways of representing functions: tables, equations, and graphs. So let's look at number 1 from homework to kind of figure out what in the world's going on here. An African elephant eats 400 pounds of vegetation each day. First, write in equation V, the number of pounds of vegetation an African elephant eats in D days. Okay, so this is the veggies. And the other important piece of information here is that the elephant eats 400 veggies every day. Alright, so if we wanted to write this as an equation, we can set it up so that V is the total. V represents the total amount of veggies that the elephant eats. 400 is your rate of change, or how many veggies that the elephant eats every day. So V equals 400D. That would be your simple equation. Then you can go ahead and start to make a table for part B of this problem. Let's see. Okay, where we've got our days on top and our veggies on bottom, or pounds eaten. So just start it out. On day 0, if there are no days, if the elephant doesn't eat for any days, 0 days, then you could assume that, yes, you will have 0 pounds of veggies. On day 1, it's going to be 1 times 400, so he'll eat 400 pounds of veggies. On day 2, that would be 800 pounds of veggies, since you're just multiplying 400 times 2. And then the last would be 1,200 pounds for 3 days. And you could keep going if you wanted to, but that table is good enough for us right now. So let's make some of the ordered pairs from that table. We had 0, 0. We had 1, 400. We had 2, 800. And we had 3, 1,200. So remember that everything that you see first, or the number you see first, represents your x coordinate, and the number that you see second represents your y coordinate when you are going to graph these points. So last, for part C, is we can graph these ordered pairs that we found from our table to represent the amount of food that the elephant ate. Okay, so the first point, well actually let me make my x and my y. Alright, so the first point that we want to graph is 0, 0, and that would just land right on the origin, our favorite 0, 0. 1, 2, 3, 4. Okay, so this is going to go by ones, and then my y-axis I'll make it by 400s. 400, 800, 16. Okay, so let's graph the other points. The second point was 1, 400, so that would be right about there. The third point was 2, 800. That's right there. And that third point was 3, 1,200. Okay, and there is your function representation. Alright, so the more days that this elephant eats, obviously the total amount of food he eats is going to increase as well. And that's why you get that linear function going up to the right, or that linear graph. Alright, let's try one more really quick. Well, actually, I'll let you guys try number 2 on your own. Just to recap, we had 3 different ways that we could represent functions. Tables was the first one, equations the second, and graphing was the third. And problem 1 did a really good job because we did all 3 of those, right? Whoa, we did all 3. We first showed an equation. We wrote an equation. Then the second thing we did was we wrote a table. And it doesn't matter what order you do this in. You can go back and forth. Usually it becomes a matter of preference, what you like to do first. Do you like to write equations first or make tables? A lot of kids will say that this is the easiest, is to make a table of values first. So then you've got your equation, and then that last thing we did was we made a graph with our coordinates that came from the table. So everything just represents the same idea, seen in different ways. Good luck on the next problem, and we'll see you next time.